Hey everybody, I am recording our lesson for Wednesday, March 2nd. I'm sorry I'm not there. I was hoping that I'd be able to be there with you today, but unfortunately I have to go to Lincoln. So here's what's going to happen. I am recording today's lesson. We are moving forward in chemical reactions 2.3, and I'm hoping that I will see you next Tuesday. But I just really appreciate you guys being flexible. And just if you've got any questions about anything, please make sure that you email me, okay? All right, so our lesson for today is you guys are going to, this is our last lesson for chapter 2. So you guys are going to apply your understanding of how atoms rearrange during a chemical reaction, and you're going to write another scientific argument. Do not freak out. This scientific argument is really short, and you're actually going to do it in Amplify. You don't have any pre-writes. You don't have anything else you're going to do. You're just going to, and it's going to be maybe 3 or 4 sentences. Okay? Not a really big deal. We're going to be in activity 2 point, or I'm sorry, in lesson 2.3, and we're going to do activities 1, 2, 3, and 4. Okay. Your homework today is to finish any activity that you don't get done in class. Also, there is a worksheet that you're going to submit. It's in here. It's how the rest form. It's a PDF. Now, I don't have any hard copies for everybody, but I think it's actually would be easier for you to complete it in GoodNotes. So it's this PDF. Go ahead and take a minute right now, and I want you to put this PDF in GoodNotes, and then we'll get to that later. Okay? Go ahead and pause the video and copy this PDF into GoodNotes. Okay, so let's go ahead and get started. All right, we're in 2.3. Let's go ahead and do the warm-up. So it's almost time to explain to the people of Westfield how the rust in their water formed. You're doing that with your scientific argument. I want you to take time right now, and I want you to write down what you have learned so far about how new substances form. List your ideas below. Here's what I'd like you to do. I want you to take time to literally write out all the key concepts that we got for PB2. So everything that's in the green section on your graphic organizer, list those out. And I don't have my list in front of me, but I think it was key concept number 4, 5, 6, and 7. Okay? Do not just write key concept 7. I want you to write key concept 7 dash and then write it out word for word. You are practicing, you are studying the key concepts, so you are really familiar with those. Pause the video, write those out, and when you are finished, please be sure to hit the hand in button at the bottom of your screen. Okay, let's move on to activity number 2. In activity number 2, we are going to test those claims again. And we got an email from Dr. Yoon. She says, I hope you've been making progress in your investigation since my last message. Today, the people of Westfield are expecting a report that explains how the rust in their water formed. To complete this report, you will need to use everything you have learned so far about how substances change into different substances. For your reference, we are listing the claims below. So claim number 1, remember, says that the iron pipes all by themselves changed into rust. So there was a chemical reaction in the iron pipes, and that formed the rust. Claim number 2 says the fertilizer, there was some sort of chemical reaction, and that formed or changed into the rust. And then claim number 2 said that the iron pipes and the fertilizer had a chemical reaction, and the product was the rust. It changed into rust. All right, so let's go ahead and test these claims. Before we write the scientific argument, we're going to use the tokens that were similar to the ones that we did in yesterday's lesson. So you guys should have at your desks the tray, And on the tray, you have the pipe substance and the fertilizer substance, the tokens that represent the atoms that make up the pipe substance and the fertilizer. I can almost hear you guys messing with those cups right now. Do not touch the cups. Put them on the tray. Leave them alone until I have given you your directions. Okay. All right. So, you guys are going to, with your partner, you're going to test the claims by trying to build rust using these atoms. Modeling atoms with tokens makes it possible for us to study atoms by counting them, moving them around, and telling them apart. These things are impossible to do with actual atoms because obviously actual atoms are way too small for us to do anything with them. So that's why we use the models. Tokens are also a good model for atoms because just as atoms cannot change type during our chemical reaction, our tokens can't change color. So for example, we've got the pipe substance atoms models, that yellow kind of amber color token, and they're going to stay that color. Now, the limitation with this model is that pipe atoms are not yellow in color. So there is that limitation. All right, so let's look at an example of how you're going to test the claims using the tokens. We're going to start with claim number 1. Now, I want you to work with a partner, so you may have to wait if your partner is not exactly where you are in the video. You may have to just wait a second, let your partner catch up to you, and then go ahead and work together. We're going to start with claim number 1. Claim number 1 says the iron pipes changed into rust. So first, you're going to choose which cup or cups to take the tokens from. Since claim number 1 is only about the pipe substance, I'm only going to take tokens from this cup. Next, you will decide which tokens to take and how many. In the pipe substance cup, all the tokens are the same color, so you can use any of them. Okay? Pipe is the pipe substance is made from iron, and that is a pure substance. We know that a substance is made of 2 or more atoms, so you can't just have, hang on, you can't just have one token. You have to have at least 2 of them. Okay? So finally, you're going to try to form rust by rearranging the tokens. So obviously those tokens represent atoms. I'm going to leave this step for you to complete on your own. Take a look and amplify, and I'm going to actually switch my view so you guys can see my amplify. So follow these directions. With a partner, use the tokens to test each of Dr. Yoon's 3 claims. Discuss whether the atoms of the substance or substances in each claim could possibly rearrange to form rust, and then complete the sentences below, recording whether or not you think each claim is possible. So, reminder, this is the atomic models for each of the different substances. Here's iron pipes, here's the fertilizer, and here is the rust. You remember that each substance is made up of repeating atomic groups. You only have to make one molecule of iron pipe, one molecule of fertilizer, one molecule of rust. Okay. I don't think you have enough tokens to make like a bunch of these repeating atomic groups. So just one is fine. If you need to remind yourself, here's the atom key. And you are going to answer these questions here. Claim number 1. You're going to decide, just go ahead and click that and tell me if you think it could or it could not. Okay. Little bit of a clue or little bit of a hint. If I were you, I would take a picture, take a screenshot of each one of the claims that you test, so that you can use that as evidence. Okay. All right, let's go back. I'm going to have you guys pause the video now, and I want you to go ahead and work with your partner and make it through each one of those claims. Okay, so when you're all done, go ahead and return all the tokens to the correct cups. So in the pipe substance cup, only put in the amber colored ones. In the fertilizer, you should have 6 purple, 6 blue, and 6 red. Don't put any of the amber ones into the fertilizer cup. So what did you guys find out? Which of the claims is possible based on your tests? I am hoping that you discovered the only way to get all of the atoms that you need to build the group that repeats to form rust is to take the tokens out of both cups. Yay! If you did, good job. That's the answer. Somebody in the previous lesson, or I think it was last Friday when we saw the atomic models, somebody looked at this. I'm going to go back to this thing here. Somebody looked at this in one of my classes and they're like, wait a second, the rust, it looks like it has a little bit of each one. And you were exactly right. We know that it takes iron and fertilizer to make rust because we can only get the iron atoms that we need to form iron oxide or rust from the iron pipes, and we can only get the oxygen needed to form rust from the oxygen from the fertilizer. So that was a great kind of prediction, and we did it. We figured it out. So what claim was correct? Claim number 3. Both the iron pipe and the fertilizer were made the rust. So now you guys are going to model what you just saw. And hopefully you took a picture of it. I'm hoping you did. If not, feel free to use the tokens to kind of figure this out. So you're going to use the results of your test to create a model using the modeling tool. We are not doing this on paper. I'm going to go ahead and have you guys switch over to your PDF. And I'll give you time to do that just a second. Let me kind of explain what you're doing. You're going to show how the iron pipes in the fertilizer changed into rust. So, let me go back here and let's take a look at this together, okay? All right, so your goal is to make a model that explains how the iron pipes in the fertilizer changed into rust. So we've got several different boxes here. Let me explain those. This is before the chemical reaction. This is during the chemical reaction. This is after the chemical reaction. I want you to notice that we have the arrow here. Remember that arrow is the yield sign. And so that means anything on the left of the arrow is the reactants. So we have 2 reactants. We have the iron pipe and we have the fertilizer. So you need to make a model of 1 molecule of iron, Fe, and 1 model of the fertilizer. And if you don't remember what that looks like, then you can go back here and take a look at this. So that's 1 molecule of iron. And you might want to make sure that you have as many iron molecules that are required here. Remember, we want to keep track of our atoms. If I only draw 1 iron molecule, by the time I get to my product, I'm going to have 2 irons. And remember, atoms they're not automatically created. So you kind of have to have 2 iron molecules. Okay, so back over here, you're going to draw 2 iron molecules here. Remember your 2 iron atoms to create 1 molecule. Remember, they have to touch and they need to be the same color as the token. And then the second reactant that you have is 1 molecule of the fertilizer. So again, go back to that card or go back to that picture and look to see how many of each type of atom are in the fertilizer molecule. Okay, then we're going to draw a picture of what happens during the change. And remember, yesterday we talked about what are the 2 steps that happen. Number 1, they break apart. Number 2, they rearrange. So I want to see what happens during this. We should see them breaking apart. We should see them moving, right? And then show me what it looks like after. So you're going to have the rust molecule, 1 molecule of rust. I want you to make sure that you balance your equation, or make sure you keep track of your atoms. However many iron atoms were over here should be over here. However many oxygen, sodium, whatever was over here, that has to be over here as well. Also, it has to be represented during the change. Okay? Last and not least, make sure that you give me a key. Draw a yellow circle and label it iron. Draw a red circle, label that, and call that oxygen. Okay? Don't forget that you have to have the element symbol in those little circles too. So, see how this, I've got the element symbol inside the red and inside the yellow. Don't just give me a red circle. Make sure that you label it O so that I know that that's oxygen. Okay? Okay, so you are here. You're writing that. Go ahead and pause. Fill that out. And then submit that to Schoology. Okay, last activity. I'm just going to remind you that during a chemical reaction, atoms rearrange to form different groups of atoms. Double check, make sure that your model showed that rearrangement, showed it breaking apart and rearranging. Oh, sorry, I thought that I forgot I had that slide in there. I should have just used that. Oh well, sorry. Okay, let's go ahead and do activity number 4, writing to Westfield. Remember that as student chemists, you are responsible for informing the people of Westfield about a situation that's affecting their water supply. You will now write to the people of Westfield explaining how the rust formed using what you've learned throughout Chapter 2. Hint, you are using the key concepts from Chapter 2 as your reasoning. Okay? In your argument, you will, number 1, state your claim about how the rust forms. Number 2, use evidence from the token activity to support your claim. That token activity that we just did, that is your evidence. You have to kind of summarize, tell what we did. We used a model to represent the atoms, and we realized that blah, blah, blah. I'm going to let you guys come up with what you want for your evidence. And then please make sure that you're including vocabulary from the word bank. That, remember, in our activity that we did on Tuesday, really helped you. If you use your vocabulary words, I promise you, you are including or summarizing in your own words the key concepts that you need to use. Okay? So you're in activity number 4, and I'm going to jump to Amplify real quickly so I can see your screen for what we're doing. Okay, so here is the Chapter 2 question. How did the rust form? We know that claim number 3 is the correct claim. So when you restate and answer your question, that is the sentence that you're using. You are using every single word in this word bank, and you're going to write your answer right here. Okay? All right, you guys, that's the last little thing I have for you. When you are finished, make sure that you go ahead and hand that in. And I think, yep, that's the end of our lesson. Let me know if you have any questions. I'll try and get back to you as soon as I can, okay? Take care, you guys. I will see you next week.